Good morning, students. I am going to go over the first lesson that we will have online for On-Ramps Pre-Calculus. And if you'll go to your dashboard and click on Discovery Pre-Calculus, we will begin in Unit 5. So I'm going to scroll down to Unit 5, and as you can see for Unit 5, it is limits and rate of change functions. And so I'm going to click that. And our first lesson is 5.1.1 Rational Functions and Asymptotes. And if you take a look, it's the exploration 5.1.1. Now, you should be doing your lesson on a separate sheet of paper or graph paper and writing down all this information. And when you are done, I want you to upload it to our page. Okay, so our first question is for us to sketch the graph for each function below. Sketch any vertical asymptotes as dashed lines. Fill in the missing information. Then make a hypothesis about where rational functions have vertical asymptotes. So taking a look at the first graph, I'm going to click over and show you that the first graph looks like this. It goes vertical here, horizontal there. And so the question is, how do you find a horizontal asymptote? You're going to see that the horizontal asymptote is going to be 0 on many occasions. So why does that happen? It says in a rational function, if the larger exponent is in the denominator, then the horizontal asymptote is y equals 0. As you can see, this is the only x, and so it counts as a larger exponent because there's not an exponent in the numerator. So in this case, our horizontal asymptote will be y equals 0. So I'm going to go ahead and click on that. Now, to get the vertical asymptote, we're going to take our denominator only, x minus 1, set it equal to 0, and when you solve for x, you will get the value x equals 1, which is our vertical asymptote. The other thing that we want to talk about is that will sometimes be a y-intercept and an x-intercept. On this particular graph, there's only a y-intercept. So the question is, where does this happen? And of course, a y-intercept has an x value of 0. So if we take our function and let x equal 0, we have 1 divided by negative 1, and our y-intercept should be here at 0, negative 1. Okay. Now, the other thing that we want to talk about is what's happening, the end behavior. As we continue to go horizontally, what's our y value going to look like? Well, it looks like it's trying to go down to 0. So the end behavior would be as x approaches 0, then y, as x approaches infinity, y approaches 0. So how in the world do I even need to say that? Well, you've done that before in Algebra 2, so I'll leave you to be able to come up with that information. Also, as x approaches negative infinity, y approaches 0 as well. Alright, so we've addressed end behavior, we've addressed any intersects. We have a y-intercept, and the x and y asymptotes. Alright, so I'm going to cut all of those off, and we will have the next question. Alright, so our next question is, when we graph x plus 2 over x minus 4, what does that look like? Cut on that graph, and it looks like the y equals 0 is no longer a horizontal asymptote. So I'm going to cut that off. So what is our horizontal asymptote? Well, it's moved up. What did it move up to? Is it at 2? Well, I can see that if I go here, that's the point at 2. So it can't be 2. And so what's in between 0 and 2? Let's try 1. Well, how do you know it's 1? Well, if you look at this equation, the x value on top and the x value on the bottom have the same exponential value, x to the power of 1. So when the x values are equal, it says if the exponents are the same in the numerator and the denominator, then the horizontal asymptote is the leading coefficient of both terms. In this case, we have, if we had this situation where we had 2x minus 3 divided by x plus 1, then we'd be looking at 2x divided by x, and the horizontal asymptote would be 2. But in this case, we have 1x divided by 1x. When the x's cancel out, our horizontal asymptote is actually y equals 1. And then, of course, our x asymptote, our vertical asymptote, we would set that equal to 0. And our vertical asymptote would be 4. And let me cut that on for you. And there you have it. So this time, we not only have a y-intercept, we also have an x-intercept. Now take a look at this x-intercept. It's crossing the x-axis at -2. And there's my point. Okay, so that's my x-intercept. Look at our equation. If you place a -2 in this equation, what do you get? Naturally, if you put a -2 on the top, you get a 0. If you put a -2 on the bottom, you get a -6. But 0 divided by any other number besides 0 is just 0. And so it stands to reason that if whatever number creates a 0 in the numerator will give you an x-intercept. And then, of course, the y-intercept, if you cancel out your x's, make them 0, you have 2 divided by -4, which is a -1/2. And so our y-intercept would be a -1/2. So we have our horizontal asymptote, our vertical asymptote, our x-intercept, our y-intercept, our end behavior as x travels to -infinity, y is going to approach 1. As x travels to positive infinity, our y value will also approach 1. Okay, so I'm going to cut all of those off. And then we will move on to the next question, which is what happens when we have x plus 6 divided by x squared minus 9? Well, I can tell you right here that if we plug in a -6, we're going to get 0. So that will definitely be our x-intercept. But x squared minus 9 is a difference of squares. And so if you were to just set this equal to 0 and you have x squared equals 9, the rule is when you take the square root that your answer is the positive and the negative value. And so we would have a positive and a -3. So when I go to that equation, cut it on, as you can see, we do have 2 vertical asymptotes and a horizontal asymptote. So what are those vertical asymptotes? They should be x equals -3 and x equals +3. Now, as you can see here, at a -6 value will give us an x-intercept. And if we look at these two x values being 0, we should get a -2/3, which is our y-intercept. But hold up, the x value in the denominator is larger than the numerator, so our horizontal asymptote should be 0. Well, if that's the case, our horizontal asymptote is 0, how can we have this point right here? So that's a question that I would like for you to answer. You may want to Google to find out, but what's going on there? How can that point be there if that's supposed to be an asymptote? Why? How can this line actually cross the asymptote? So that's a point that we want to talk about. And then, of course, there's the issue where there is a hole in the graph. And I'm going to go back to the lesson. We have this issue here. It says to use your conjecture to predict where the rational function f of x equals the quantity of x squared minus 9 over x minus 3 will have a vertical asymptote. Now, if you just look at it sight unseen, you would think that this equation has a vertical asymptote at positive 3. But when we actually graph that function, we see that it actually, cut these off, there is not a vertical asymptote of 3, actually. Oops, sorry. Still got information. We have, there we go. It looks like that. What's going on? Why does this equation look like this? Well, something happened. When you have an equation and you factor it, the quantity of x squared minus 3, x squared minus 9 is x plus 3 and x minus 3. And so it would be something similar to this. On this equation, I have x squared minus 5x plus 6 divided by x minus 2. If I were to factor this, I would have the quantity of x minus 3 times the quantity of x minus 2. In that case, x minus 2 would cancel out, and it would create a graph that looked like this. So, there's a hole in the graph when after factoring, the denominator cancels out. So in this situation, we have x minus 2, x minus 3 divided by the quantity of x minus 2. It only leaves the equation x minus 3, which is a linear function with a horizontal, with a y-intercept of -3. But because this function did have an x minus 2 in the denominator, at 2, we still can't plug in a 2 into this equation. So at 2, what happens, there is a hole in the graph. And if you look in the table, if you are graphing this online, you'll see that at 2, the equation is undefined. Okay, so if we go back to our lesson, the next thing we want to do is answer this situation about the third case where there was a point on the line that crossed the horizontal asymptote. Why did that happen? And if it happens on a horizontal asymptote, question 8 says, do you think it's possible for it to intersect its own vertical asymptote? So these are questions that you're going to need to answer, and you can put that information on a sheet of paper, number them, and entitle your lesson 5.1.1 Rational Functions. Make sure you have your name and period at the top, and I can grade that for you. Then we can move on to our homework. The homework, if you will click on Files and go to Homework, you can click on it here or here. We want to look at Unit 5 and 5.1. Alright, so if you look at 5.1, several things come up, 5.11 and 5.12. We're going to look at 5.11 this week. So I'm going to click on that, and you will see that there are several graphs that you need to graph. Now I particularly want you to graph all 4 of these, 1, 2, 3, and 4, because there's something that happens when you put in numbers for these letters, CD here. What happens when, we've already talked about what happens